Right, whatever. All right. Hello, everyone. Today I'll be giving you kind of an introduction to C++. I'll first talk about why we would ever want to use C++, and then go into a bit about the basic syntax of the language, how to write code, how do you define variables,
I
and
can't hear you.
you're not here. Wait. Wait. Yeah, everyone can hear. Okay. Anyways, yeah, we'll just be talking about the basic syntax and yeah. So first, why do we want to learn C++? Well, C++ is useful primarily because it is very fast. Also Python is better if people need to like chill out. Python has its uses. Python has, compared to C++, Python has a lot of more libraries. And so there's just a lot more code. Yes, Python is used for AI. It is easier in what sense? I guess kind of the syntax is easier. Python's more lenient. C++ is more strict, but it's very efficient and it's very fast. And also it's very powerful. And for competitive programming, which is what I and the other instructors in this course will all do. All of us use C++ because it is such a fast language. By the way, competitive programming is what people do for like USACO. So yeah, if you're interested in that route, yeah. By the way, our instructors are USACO Golds and Platinums. So yep. Yeah, some people who like playing Hoyo games have noted that I put Genshin Impact here. And yes, Hoyo games are coded in C++, and so are Nintendo games. So gaming, competitive programming, lots of uses for C++, many reasons why you'd want to do it. None of our instructors made camp this year, unfortunately, but Platt is still very respectable in ORs. Is Alex here? Alex? No, Alex will be your instructor tomorrow. Is he not here? Whatever. Anyways, all right. Basic program features. Alex, is that you? I don't know. So if we go on to REPL, which is what I'll be using primarily because I don't want to be switching through 17 screens and sharing all of them. So yeah, I literally just load it into a Replit file and then it has some code pre-written for me. And so let's first decompose this code piece by piece. So first line is this hashtag include, and then you have the word IOStream wrapped around in angle brackets. So what include is include is a keyword. Basically, keywords are just words that mean something special in programming. So like include is a special word, int is special, main is special. Stuff like if you see it changes color compared to if I just type some random stuff. So those are keywords. You can't have variables be named after keywords, which is important. So you can't have a variable named for, but I'll go into that a bit later. Yeah, so what the include does is it takes IOStream, which is a file within the C++ library, and then it basically allows the code to access its contents. So include IOStream, yeah, kind of like Python imports, but a bit different. So include IOStream, honestly, I think it should be in most, if not all, of your C++ codes because it allows this cout to work and also the counterpart of cout, which is cin. Cin, cout allow the program to input and output stuff. And this is really important, even if you're working with code that maybe doesn't use standard input output, maybe it prints stuff into files. It's still useful to have IOStream in case you want to debug something and check if what you think the variables are different. Yeah, so along with IOStream, there are other important files like vector, which you will be talking about later, and some other important ones in competitive programming are like algorithm, and maybe I can spell correctly. And as you can see, vector, it gets this brownish color. So that's how you can tell that you made a valid file. Replit is nice. So like if, oh my God, I've spelled, never mind, it does not do that. But if I like, that's awkward. But if I like misspell include, REPL will tell me, something's wrong. So yeah, after includes, we have int main with parentheses and then brackets. So those of you with some, what does IOStream do again? IOStream allows you to input and output stuff. Actually, I'll remove this right now, and then you'll see that first, can I hover over this? Yeah, use of include identifier std. So this means that the program doesn't recognize cout. You've just said something, you've just told the program to do cout, but you haven't told it what couting is. So what IOStream does, it tells the program, cout says, oh, print this out. In this case, this is hello world. Those of you with some experience have already said to using namespace std, which, oh, can you run it? Sure. Yeah. But those of you with experience have already suggested that I use using namespace std. And while perhaps in higher levels, this is considered bad practice for beginners and honestly for competitive programming, because nobody wants to type std : like 17 times throughout their code. For us, using namespace std will be really useful because this allows us to ignore several important things which need std, like cout, cin, and vector. So if I do not have using namespace std, and then I just have this here, once again, the compiler doesn't understand what cout is. But this time it actually gives us a suggestion, maybe, oh, maybe you need a std : to actually have the program know what the cout is. And then, so if I use std : that allows the program to understand. If I use using namespace std, that also works. So yeah, include and using namespace std. One important thing, yeah, are semicolons. You have to have semicolons at the end of each line. And this is not like for you Python people. This is what I kind of mean by C++ is stricter, because why semicolon? You can ask the developers of C++. I guess probably just because semicolon isn't used anywhere else. And in English grammar, it also represents a line break. And well, okay, Victor says this is also used in Java, and he is correct. Semicolons are also used in Java. In fact, most of the basic syntax from C++ and Java are actually pretty similar. Okay, we have a person asked, what if you don't have it? And I will actually demonstrate. If I have this, then red arrow pops up and it says expected : after expression. And as you can see, I can't compile this. The compiler is going to be mad and say expected : after expression. So putting the semicolon back will fix it and allow the program to run hello world again. And the engineers try out the semicolon typing key, RIP. I don't think there's such thing as syntax errors in C++. Well, sure. Maybe not classified as syntax errors, but they are errors nonetheless, and they're errors with their syntax. So they're syntax errors in every way, maybe besides the name. The point of the semicolon, once again, is to break off lines. So I'm just going to type some other stuff. And if I use the semicolon, it's going to break stuff off. So yeah. Next, main function, yeah, int main, you need to have parentheses after the main, and then you need to have curly brackets around the main function So it's just these two. You can't be missing any of these. Yeah, basically, it main is the main function. Yes. So you'll be going over this in a lot more detail in future lessons, particularly with functions. But right now, int is the return type, main is the name. The parentheses are supposed to list parameters, but main normally doesn't have parameters. And then the body of the function, which is where the code goes, it's surrounded by curly brackets. So yeah, that's the main function. Additionally, I guess in the main function, you could also have return 0, which is the classic code works fine. Sometimes, well, in my experience, sometimes when my code has some undefined behavior or I've done something that kind of breaks down the memory behind the code, you can have non-zero exit codes, and that will tell whatever the is calling the main that, oh, there's been some error somewhere and probably should abort whatever it is you're running. So the return 0 helps. You actually don't need it though. As you've seen, like it worked fine here. And yeah. All right. Next, oh no, this is the next. Comments. Yeah. So comments are really important for higher levels of programming. If you take like CS courses, then there's going to be a really big emphasis on there's going to be a lot of emphasis on documentation. So the documentation basically allows you to explain your code. And a question, let me get this straight. Main is the main function, semicolon behind every line, then other stuff. Sure. Yeah. Comments make the line in front of the comment not used in the program, and used if to want to remove it but keep the code. Yes, those are two big functions, I guess, reasons why you'd use comments. The first is to describe what I'm doing. So boom, I'm about to print hello world. So yeah, I can do this and it can tell me, I can do this and then anyone who's reading this code will say, I'm about to print hello world. Obviously, if you have an experienced programmer, they will know that, okay, this prints hello world, you're not telling me anything useful. But if you have really complicated algorithms or just long sections of code, it's going to be really useful if you have comments to describe the intended behavior of your code. And this will also allow people, if they're debugging your code, to kind of understand what your program is trying to do and if it's not doing what it's supposed to do. The other function of comments is to remove out unwanted pieces of code. So like if I have lots of random stuff here, and then I say, oh, I don't want to actually print this out, I can comment here, put these two slashes, and then the code, oh yeah, it gets grayed out on Replit. If you have other places where you run code on, maybe it gets, it turns a different color, maybe it doesn't. But anyways, the comments basically kind of hide the code from the compilers. It basically tells the compiler, skip over this code. We're not going to skip over whatever is on this line. We're not going to care about what's here. So yeah, if I leave this open, you will see that this will execute and print out 9. But if I comment it, then this second scout never executes. Oh, by the way, this endl basically allows you to make a new line, as does this \n. This is what's called a new line character. This also makes a new line as well. Yeah, and with cout, the intricacies of cout are really complicated, and I don't really want to explain that right now. But basically, you can kind of type two main things. One is like stuff with variables, most likely with ints. So you can say cout a+5, and then this will just print out, evaluate what a+5 is. It's 9, and then print it out. You can also print out a string literal, and then it'll print it out. And also you want to put two left left angle brackets between the cout, whatever it is on your print, and then whatever you want to print, end out. What does \n? This backslash is important. \n is the new line character. Oh, right. So okay, \t is tab, but like nobody uses that. It's weird. Basically, you'd only ever want to use \n, I feel like. I don't see what else is useful. I had a question. What is the difference between \n and an endl? They do the same thing. Endl does something complicated called flushing the output, which I'm not going to explain in detail. So within USACO, it's recommended to just do \n whenever possible because there's no need to spend time normally flushing the output. Can you make a game or something? I could, but it would take me time and we have stuff to cover. So yeah. Endl is probably used more common use. It's used to have next out printed in a new line. Well, \n kind of does the same thing. Let's see. All right, I guess that's all the questions resolved for now. Oh yeah, I forgot to talk about multi-line comments. So if you have a large section of code, on Replit, command / allows you to comment out everything. But you can also alternatively have \**, which opens a multi-line comment. And you don't see this doing anything right now because I don't have the closing star //, but this will comment out everything in between. So functionally, it's the same as if I just did this. I had a question. Do I do USACO? Yes. I am in gold. I choked on the last contest. We don't. That was kind of sad, but yeah. All right. All right. Statements. Basically, they do stuff. Congratulations. Okay, you understand what statements are now. Right now, we're just gonna deal with I/O, input, output, also variable declaration. I guess those are different types of statements. Later on, you will learn about if. You will also learn about for, and then you also learn about while, and other stuff. But yeah, basically, congratulations, your code can do stuff now. Good job, I guess. Yeah, just I/O for now. Yes, and other stuff. Code can do a lot of stuff. Mine, it's command /. Yeah, you can command / to quickly comment. Yeah. We can print ints and strings. Yay, congratulations. You can print out hello world. Retype the hello world code, and then you've passed the baptism for CS, I guess. What is a debugger? That's a good question. I'm not familiar with debuggers myself, but I believe they kind of run your code pieces at a time so that you can basically you can check what variables are at a certain point in the code. Right. Variable time. Variables are important. You store stuff in variables. You can't really code without variables. So yeah, let's what does cout stand for? That's a good question. Not out, I guess, for output. C. Oh no. See. Yeah. So variables. Not clear output. It's not console out either. All right. On to variables for like the third time. Yeah. So basically, this is the essence of a variable definition. So I have to state the type. So unlike in Python, where you can just say x equals 4, here you have to say int a equals 4 and specify that what you want is an integer. And so if I don't specify, it's going to be confused. It's not even going to recognize this as a variable declaration. It says, oh, you have a variable, but I don't know what it is. So if we put the type and then the variable name, then that allows us to define a variable. So I can do two things when I'm declaring a variable. First, I can just declare it randomly. And then this right now I now have a variable A, but okay. Who wants to guess what is currently stored in the variable A?
Number?
Nothing. Still an expert. Number, be more specific. Which number? Nothing. 0. Lots of zeros. All right, let's test it out.
Oh?
Okay, this is definitely not 0. The what? What? Wait, it changed. Uh-oh.
It's just a random amount?
Yes, it's a random number. You haven't told A what it is. So actually, if you define a variable locally, which I guess we'll talk about more with functions, but if you define something in the main function, it will be something random. If you define something in the functions, you're not gonna assign anything. Unless you define it outside of a function, which yes, you can do. If you do this, what will it print out now?
0.
0. Anyone else say anything different? Not a random number. 6. Nothing. 113. All right. Yeah, no, it becomes 0 now. Then we can test that it's actually 0. So if we define this, what's known as globally, which is outside of any function, we get initialized with a default, the default value, or like the initial value. Let's try this with strings. So to declare a string, I have string. Okay. And I was talking about how you can't name variables after keywords. So I can't say string equals string. Wait, there's no way I can do this. Okay. Normally you shouldn't do this because it gets really messed up. And then, so if I try to print out this string, then it's going to be really weird. I'm not sure if it actually will print out. If it will print out, that would be so weird. But yeah, no, this is bad practice. You should definitely not do this. You don't know if you're actually making a string. It confuses the coder. If you're a competitive programmer, maybe you want to confuse whoever is reading this. But if you're literally any other type of programmer, this is bad. Don't do it. Yeah, us competitive programmers are quite quirky. We do weird stuff with our code. We follow absolutely zero conventions whatsoever. So like, yeah. So normally it's more preferred to name something as str, which is actually what competitive programmers would do probably because it's less characters. And then this is a definition. If we do this, what do you think will happen if we try to assign it? Will be a random string?
I think it'll just be nothing.
Nothing? All right. It just was nothing. Okay, that's kind of a nothing burger. In Java, this is bad. You should always initialize stuff to empty string. But I guess in C++, it should be it's fine. I guess globally, then this will also just be nothing. So yeah, ints and strings, I would argue the two most important variable types. But of course, there's other stuff. And for right now, these are the basic ones: int, float, string. Later on, you might learn what a vector is. You'll also learn what arrays are. Oh my god. What about PHP? I don't know PHP, sorry. These are more complicated. They will be covered in future classes. Right now, we're sticking to the basics. How do you even use those? That's for, I believe, Ethan to answer. Yeah, so int, float, string. Define a variable. You have variable type. Vectors. That's massive. You have a variable type. You have your variable name. Depending on, quick syntax thing. Depending on who you're asking, you might have people who say my variable and just not use capital letters and use underscores. You also have people who do this. Really, I don't know, up to the programmer, but basically with syntax, be consistent. And that should be it. You should initialize local variables, otherwise you get the random stuff that was there before. Yeah. All right. Integer, int. Okay. So I have a code snippet on the right that actually no, I'm gonna build up the suspense. All right. Int v. So the maximum value an integer can store is around 2 billion. So if I have v equals to 2 billion here, then it can print out 2 billion just fine. All right. Well, what happens if I try to store a bigger number like 3 billion? What do you think this will overflow? What do other people say? What will happen here? 21 overflow. No, nothing. It will print out 3,000.
Nothing.
You can guess by the yellow line under 3 billion that maybe we've done something wrong. It commits error. Okay. Let's give it a test. Oops. 3 billion is not a negative number last time I checked. So the people who said overflow are correct. Your code basically bonks. The int is the 32-bit. There's stores 32 bits, and this is too big of a number to store. So what it does is, the inner workings are really complicated, but basically you can't trust what this value is. Yeah. So how do we combat this? I will tell you a bit later. Does it use floating point? No, that's for floats. Floats have floating points. Who would have guessed? Anyways, so you have an int that's too large. I guess you can also have negative integers and then print them out. And then, yeah, cool. Integers. Okay, back to the question of 3 billion. So what should we do with 3 billion if we want to store such a big number? And sometimes there are uses for storing this. What is the least value? Ooh, good question. The maximum value is 2 to the 31 minus 1, I believe. And the min value is minus 2 to the 31. Why there's one more negative numbers than positive numbers? It's really complicated. It comes down to a process, or I guess a technique that's known as 2's complement, which is interesting. You can definitely check it out later. Let me actually search up what the value is. Oh yeah, this monster 214748368. Okay, sure, whatever. That value I don't really use. Okay, but what if we want to store 3 billion? How do we do this? Long time. Sum of 2 variables. Higher bases. Those are all interesting strategies. 21. I don't know what 21 is. I don't think 21 does anything. Lucas, if you keep spamming the chat, maybe I'll have to kick you out. Who knows? The variable value still eventually leads to overflow value. Not sure. Can scientific notation be used to store huge numbers? Well, scientific notation is kind of how we write stuff, right? We want to say 3 equals 3e9. And basically this e just, and it should, by the way, you cannot declare the same variable twice. Don't be like me. I'm just going to call this v2 now. So yeah, so actually this stores it as a floating point, but that's floating point is for later. So we had an idea that to store this in a sum of two variables, but what if we have now we have 3 trillion. Now you can't store it as just a sum of two variables. You have to store it as a sum of so many variables, which is costly. And so the person who said long time is correct. We use long. Basically, this makes an integer more powerful. So let's denote these x's as what an integer can store. So like if each of these x's are zeros and ones, which is what computers store everything in. So each of these represent 0 or 1. This is a 4-bit integer. And now if we want to store a value that's bigger than a 4-bit integer, so the biggest value that can store right now is 111, which is equal to 15. But if we wanted to store 16 into it, what we can do is increase the size of this. And now suddenly we can store 15 really easy. We can store 16 really easily. Yeah, like this. Cool. Yeah. So what long does is kind of similar. What long does is now, instead of having the maximum value be 2 billion, your maximum value is now about 9 times 10 to the 18. So let's do some counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And we print it out. And I say, okay, it actually did it. So yeah, does one long do something different? Okay, yeah. Sometimes if you have one long, then it works. I would assume Replit is okay right now with doing, yeah. But on some computers, long is the same thing as an int. So it's much safer to have two longs, have a long, and then be able to store larger values. So my CPU exploding. Okay, that's my CPU's problem, not mine. Does int work? That would be really funny. Unfortunately, not. I guess long is just quirky like that. Int long, no, you can only have long. Long int, no. Unfortunate. Long, well, sure, you can consider long as a big int. Oh yeah, in Java there's something called a big integer, which will allow you to store big integers, but okay. long, God. So yeah, integer overflow. I did this example again with 10 to the 12. Yeah. And long. You can also store negative numbers. Floats and doubles. So yeah. If you want to store decimal values, like 1/2. Ooh. Okay. Who can tell me what this prints out? 1/2. Int v equals 1/2. 1. 0.5 is an integer. 1. Should we give it a test?
1/2?
Okay, it's not 21. 1. Stop spamming. Oops. It wasn't right, Sag. It's not 1. You didn't print out 1. Why did you not print out 1? Okay, at least you didn't say print out 0.5. 0.5 is kind of pointless. 0.5 defies all logic of ints. But yeah, so what happens is it takes this 1/2 and it rounds it down. Floor, yes, correct. So if you have 4/3, it's floored down to 1. If you have, yeah, so basically just takes the floor function. But now if we want to actually store what the value of 4/3 is, let's just use a float, right? Now we can store 1.32333, right? I know a good amount of CVC. I don't know. So wait, so does everyone agree that this will work? That using a float will be okay? Yes.
Maybe.
No.
Yeah, probably.
Yes. What if it's a really big decimal? Oh yeah, I'll get into that later. Yes. And oops. Okay, so what happened was that your declaration of a float came way too late. So what the compiler did was that it evaluated this first. It said, okay, let me find the value of 4/3, and then I'll store this value into a float. And so what happened was that it evaluated 4/3 first, and it treated 4 and 3 as integers. And so it did integer division on here. Okay, so now we actually want to print out 1.333. What do you propose that we do? How do we make it into a float? Or make this value into a float? 4.0 over 3.0. This is not...
Put the float before the 4 over...
So like this?
Yes. I see it's still that.
It's red. Okay. But then the 4 is wrong. I see two people say 4.0 over 3.0. That is one way to do it. Now 4.0 and 3.0 are both interpreted as floats, and as you can see, and you now get 1.333. Actually, you can do it with just one of them being 0.0 because float over int would be considered a float. But yeah, this works. The other way to do it is called typecasting. So basically, you say to your compiler, I promise that you can take this 4 and you can turn it into a float. And I promise that this should come out as a float. Yes, you type more stuff. Okay, whatever, sure. And then it says, oh, okay, yeah, I trust you. It took this 4, it implicitly converted it into 4.0, and then it just divided by 3. Then you just do 4.0 over 3. Yes. Yeah. So that's how you can do it. What if you lie to it? Ooh, yeah, let's try lying to it. Okay. We're doing a good job lying, right? Oops. It seems like it's found out our lie. Uh-oh. That's sad. Okay. And then we get errored out, and then obviously this code can't run. So yeah, that's floats. So you can store this. You can store decimals. You can store, I guess, can you store large numbers? You can store large numbers. You can't store excessively large numbers. You also get into bad problems. Can you store 1, 2, 3, 5, 6, 7, 8, 9, 0? That's not going to work because of the limitations on the sizes of instant floats. You can also go, we can also test this. How many decimal places will floats allow you to store? Because what's the limitation? I'm actually not too certain. And there's a reason why I almost never use floats in favor of this next structure. 5, maybe. I don't know. I don't remember. You can store multiple floats. What do you mean you can store multiple floats? You can have multiple float variables. Floats v2 equals 0. This, I guess. But basically my point here is that float can only store a certain amount of digits. So it's chosen to print out some of these, but it's been weird. I think there's a really famous example. Let's see. Can I replicate it? Let me try. No, okay. I'm not quite sure what Ghostwriter is. Never mind then. Okay, so what if we want to store a value this large? What do you think we can do? What did we try last time? Long. Okay, some sort of long for floats. Long. Short. Okay, short is also working within the realm of ints. Long is also working in the realm of ints, but that's the gist of it. So what we can do is we turn this float into a double, and this will give us double the precision. Oh my god, so cool. Yeah. Now you can print longer stuff.
What about double double? What about double
Doubles
double
don't
double
exist,
double double?
unfortunately. Short, long is not
Do the
possible.
doubles?
Triple is not possible.
You try doing it 9999999999999999999.
Yeah, wait. Good point. Wait, can we convince that it's one? Can we convince the compiler it's one? Yes, we can convince that this is one. Oh no, this is not one. Sad. Okay. This is what's known as floating point error. It's basically kind of due to the fact that we can't represent all fractions as okay, so everything in a computer is stored in terms of base 2, but we can't store all fractions in terms of base 2. So yeah, you could still use long double, yes. Okay, this is the longest we can go with doubles. So I think now we made it snap out of it. Okay, never mind. Ooh. Okay. So weird stuff happens here. When you print it out, it does some rounding for you. There's a way to make sure you print out a set amount of digits, but it's beyond the scope of what we're doing right now. So yeah, doubles are usually much better than floats unless you're like really pressed for space. And yeah, so usually whenever I code, it's doubles and long doubles are my go-tos. All right, it's exercise time. Okay. Yeah. Oh, I haven't told you how to use Cn yet. All right. First, print out string. All right. So I'm just gonna have everyone tell me what to print, how I should print out a string. Short, long, possible? No. All right. Let's say I want to define a string Andrew, which is my name, by the way. Name reveal. So cool. Okay. What would I start? How would I start? I'll turn group chat back on. How should I declare a string? C++ input, I'll get into it later. Let's see. I'll give you spell shoot. Yusuko Gold doesn't know how to type. Okay. Ooh. Okay, seems like most of you have got, I see a few good wrong answers. And I'll say why they're wrong. All right. First, okay. Correct answer is string name equals Andrew. And I'll go over some of the wrong. Oh my God, this guy used flush. Oh my God. Yeah, but okay, this is the correct one. We have our variable type. We now know name is a string, and then we assign it to the value Andrew. Okay, common wrong answer number 1, not having quotes. And this confuses our compiler because it says, hey, we want a string, but what if Andrew's a variable? What if I had int Andrew equals 4? And then we try to cast a string into it, and then all of a sudden, oops, sad. Okay. So we need the quotation marks if you want to do a string literal. Basically, if you want to type a word and then have it be interpreted as a string, you need to create quotation marks around it. For a single character, you just use single brackets. String, yeah, whatever. Second common mistake, forgetting the semicolons. It's going to take some getting used to, obviously. For those of you who this is your first class, you probably won't remember to put semicolons all the time, but as you code more and more, it just becomes second nature. Please write ghostwriter at the end of class. You know what? Fine. I'll stay after and have people tell me how to use ghostwriter. Yeah, sometimes honestly in normal writing, I start putting semicolons at the end of sentences just because it's so second nature. It's really easy to access the semicolon. Yeah, semicolons pog. Okay. Third mistake, capital S. Okay, this is what you would do if you're someone who did Java, and then in Java you have to capitalize your S, but in C++ it's different. All variable declarations are solely lowercase letters, and so yeah, so this is how to find a name. All right, now how do you print my name out? If I want to print my name out, yeah, the exercise absolutely ask for an username. I will I will explain CN later. But for now, how do I print out my name? See out name and L. Okay, a lot of them. I'll give perhaps half a minute to another minute for answers to come in. What grade are you in? I am rising 11th. I've been called a boomer and now I feel sad. Rising 6th, that's young. See out name and L, see out name \n. Wait just a bit longer. Name Andrew not shiny needs an L. Bro. Sad. Okay. Somehow that print line name. No. Wrong language, wrong language. Okay. Correct answer is see out name and L semicolon. Okay, less of you forgot your semicolons. Good job. Still some errors, and I'll go up. I think I saw 2. Alternatively, you can also do. Ooh, I saw a good one. I saw a few good other wrong answers. Did I? Alternatively, you can also. Yeah. Okay. Never mind. First mistake, or at least the biggest mistake, is putting quotes around this. Okay. Turns out you don't actually need quotes here. Guess what this will print out? This will print out name. Okay, that's definitely not my name. That's kind of sad. Yeah. So you put I'll expand a bit more on quotation marks. So you put quotation marks around strings that you want to be stored as variables. So I want to store my name Andrew as a variable, but here I'm trying to print out the variable name, which contains my actual name. So I shouldn't use parentheses here. And if I have a string here and I see out it, this will print out the contents of the string. So yeah. I also saw some people with \n here. I saw some people put \n outside. No, it actually has to be inside. But this will just print out name within your line. Oh, this doesn't even work. Yeah. What you need to do is you need to do this, and you need to delimit this separately. I'm not going to explain in detail what this is because it's honestly a bit complicated. So yeah, when I forget to put, wait, does USICO take you off if you forget to new line? That's gonna be kind of sad. But yeah, this allows you to print out my name with the end, the line end. Okay, and now I'll tell you about CN. So basically, CN is very similar to cout. And this is my name. And then so the syntax is this, except you don't have an NL because you don't need to have a new name. You don't need to have a new line after your name because that you're inputting stuff. So this CN and these angle brackets are now pointing to the opposite side, and then you have name. And so what the code does here is basically when it sees a CN, it will stop. It will not do anything until you give it something to say. And so it's just gonna keep waiting until I give it a name. And then once I type enter, it will continue running and then print out my name. So that's input and output. So yeah, that's basically the gist of inputting and outputting. You can also, if you want name to be an int or something, and you do this. Okay, also make sure that you're not like breaking your code, because that would make the code do some really weird stuff. And you can't really trust this. Surprisingly, you can also, but you can do this, and I spelled it wrong again. You can store an integer in a string, and then just have the name be called string. Yeah. Input and output. Okay. Final exercise for today. Have the user input their scores for English, math, and science finals, and calculate the user's average score. Okay. Let's bring this stuff down. All right. Because we want to be nice, we want to tell them, you want to ask the user actually, scores. So I want to have this. How do I output that to the user? How would I print out this string? Terminal works on Mac, yes. There are a lot of places where you can do C++. Terminal works. There are other more specific stuff like VS Code also works. Command prompt? No, not command line arguments. I was actually talking to one of the instructors and he said he's not going to teach it. Yeah. But how do I want to, I guess, let's go back to the question. How do I want to ask the user to, or print out this statement with cout? Cout then can with string. Cin. Is it cout or cin? Which one do we want to use? What do the letters think? Both. Well, you will use both. I'm just talking about the first step right now. Cout or cin math. Okay, Alex, you're skipping a step. But the running out of time, so yeah, basically I'm going to use the power of copy paste and copy paste it to the wrong line. And yeah, print it out. Sophia, you need to remember to put the quotes because this is too much stuff for a variable name. Also, don't name your variables some really complicated and convoluted name because it's really hard to type. Like, don't stop. Like, this is torture to anyone who not only writes this, but also reads this. Okay, now I want to input their score. So how would I do that? I guess we can ask for them separately. Cin score 1, Cin score 2. Yeah, I thought you'd ask them separately. No, we can do that, sure. What do the other people say? What are your final score? Seeing that? Power copy paste. True. Give everyone a minute to think about it. This is what's up here. We're now asking for the to input a score. How will we do that? Input a score. Cin, yes. What's after cin? Cout? No. Double right facing brackets. Cin score 1, score 2, score 3. Ooh. No. When does the class end? In 2 minutes. The equivalent of Python map. No, that actually doesn't work. So what we want to do is we have, and just label them ing score, and just seeing it like this for now, and then power of copy paste, yeah. What's the difference between CN and Cout? CN is input and Cout is output. Ing score, and now math score, I guess, and then sci score. But what's the problem? There are red lines here. Why are there red lines here? Oh, I showed it. Types. More specifically, or I guess the general problem, I think they're the opposite of each other. That's sure, you can put it like that. It should be a string. Should it be a string or an integer, everyone? What do you all think?
Integer.
Yes, it should all be integers, and we haven't defined them yet, so we need to define them. I prefer to define them like right before you like initialize them. And then, oops. And now, all right. Now, how do you calculate the average?
Add all the scores together and divide it by the number of scores.
Okay, so we have average equals being the score. By the way, you will need order of operations, size score, and then we divide it by 3 because there are 3 classes. And I spelled math score wrong. All right. Int average. What else do we need? Score on score to like that.
Don't forget to print it back out.
Yeah. Technically, if you want to be nice, is to do this. Now this is how you print out a string and a variable at the same time. All right, let's see how it goes. All right, what if like, okay, I'll say I'm an absolute Chad. I got 100 on all of my tests because that's what I can dream of, and you miss my average is 100. That works. Now, if I ask my average is 100, my math finally is 90, and I got 80 on my science, my average is 90, and that works well as well.
What if you type a decimal score? Then what will happen to the code? Will it go haywire?
It won't necessarily go haywire. It will floor the decimal. So we're assuming that you got integer scores. If you got floating point scores, then you just use double. But I want you to show an error here. If we have 100 on English, we only got 90 on math, and we got 90 on science. Oops. Last time I checked, 90 plus 90 plus 100 does not equal, and divided by 3, this is not 93. Oops. What happened here? 493.33. Float, rounded it. Yup.
You're running it down.
This could be a float. Anything else? Long float, double. Okay, sure, if you want to be cheeky like that. Well, there's something else that we need to do, because as you see here, if we continue to run it, it still says 93. Uh-oh. UT on your math test. No, I am a good duck. I talked about this before. What do you put a score higher than 100? Then you get greater than 100.
It does not work though.
Ooh, someone said the right answer. Good job, Alvin. 3.0. You need to make sure this value actually turns out to be a float. And then if we put 100, 90, 90, that does it. Good job. And that's it. That's day 1 done. So hopefully you learned something. We'll be back here tomorrow for if statements and for loops. And no, I did not cheat on my finals. Please stop casting doubt on my character. All right. Goodbye, everyone.